There's actually a lot more that we can talk about with capacitors and the chapter 25 topics, but I'm going to end it with one final note here, and that is a standard RG6 coax cable. Okay, so the RG6 coax cable has an inner conductor here that has a core with a diameter of 1.024 millimeters. And then it has a sheathing around here. The sheathing, shielding is electrically conducting, and it has a diameter of 4.70 millimeters. And it's filled with polyethylene. And so the polyethylene in there has a dielectric constant of 2.4. So if we are going to have maybe 12.5 meters of cable, then I want to know what is the capacitance of that cable right there. Okay, so right away we know that we're going to need to know the radius of the inner cylindrical part and the radius of the outer cylindrical part. So R1 is going to be half of that. So half of that is going to be 0.512 millimeters. And then R2 is going to be half of the shield. So that's going to be 2.35 millimeters. This is a cylindrical capacitor, so we know that the capacitance is given by 2 pi epsilon naught L over natural log of R2 over R1. Oh, but wait, we have a dielectric in there. So how does the dielectric change things? It's really simple. It's kappa times 2 pi epsilon naught L divided by natural log of R2 over R1. That's it. That's the only thing that you change, is that one term is added in there. And so that's for the dielectric. And so now what we do is we just plug in numbers. So the capacitance is going to be equal to the kappa, which is 2.4, times 2 times pi, times epsilon naught, 8.85 times 10 to the minus 12 farads per meter, times the length, which was 12.5 meters, divided by natural log of 2.35 millimeters divided by 0.512 millimeters. Okay, now then you might ask, oh wait, I did not convert those millimeters. Is that a problem? Well, the units cancel. So it turns out it's not a problem at all. Okay, so what we come up with is 1.09 times 10 to the minus 9 farads. Okay, and so you can write that several ways. You could leave it like that if you want. You know, that's going to be 1.09 nanofarads, except normally we don't use nanofarads. So that could also be written as 0.00109 microfarads, or it could be 1,090 picofarads. Okay. Any of those four ways of writing it is equally correct, and I would take any of those.